A parallelogram is a quadrilateral with two pairs of parallel sides. That's the definition of a parallelogram. But parallelograms also have many useful properties, which we can prove. Properties are additional features of a parallelogram which extend beyond the definition. For example, a possible property of a parallelogram is that opposite sides are congruent. But we don't know this property is actually true until we prove it. Let's try to prove that, given a parallelogram, the opposite sides are congruent. Let's begin by stating the obvious. AB is parallel to DC, and AD is parallel to BC because of the definition of a parallelogram. Let's draw a diagonal here. Now let's label these angles 1, 2, 3, and 4. 1 and 2 are alternate interior angles. Because these lines are parallel, 1 is congruent to 2 by the alternate interior angle theorem. How about 3 and 4? Because these lines are parallel, 3 is congruent to 4 by the alternate interior angle theorem. Look at the two triangles. BD is congruent to BD by the reflexive property. Can you prove the two triangles are congruent? An angle, side, and an angle of one are congruent to an angle, side, and angle of another. So triangle ABD is congruent to triangle CDB by angle, side, angle. Remember, we are trying to prove opposite sides are congruent. AB is congruent to CD, and BC is congruent to DA because corresponding parts of congruent triangles are congruent. We successfully proved the property that if a quadrilateral is a parallelogram, opposite sides are congruent. A parallelogram has a definition, but it also has useful properties that we can prove. We have proven the property that a parallelogram features congruent opposite sides. We can use this property as a shortcut in our future proofs.